observing the graph, and so this one definitely the product of inertial IXY is not 0. And for sure the Y and Z axes are not the principal axis. So the first step, we have to find out the principal axis, and from there we decompose the moment into the principal axis and starting from there. So the first step, because the Y and Z axes are not the principal axis. So step 1, we locate the principal axis. And usually, for example, for these questions, we are given this one. Let me drag down this one a little bit. Good. So for this one, usually we won't be given those kind of things. So the fundamental quantities, if we are not given, you have to calculate using the fundamental the properties. And I believe today is Monday. Today is Wednesday, Monday, Friday. Friday last week we have 1 or 2 examples show how to calculate those kind of terms. Okay, so refer to the lecture notes there. Unfortunately, last Friday we don't have videos, and we don't have videos. So, but for those kind of things, you can easily check out on your statics. Your statics should be no problem. And or otherwise, I have the lecture notes. You can come. I can make a copy for you. So for this one, we are given those things. Then we can see, make a circle, and for the circle, we calculate the average. The center is Ix plus Iy divided by 2, and so for this one, the center is at 1.254 times 10 to the 6 millimeter to the 4th power. And then we calculate R equal to Ix minus Iy Q squared plus Ixy squared. And R calculation 1.0245. Okay, so the center is a little bit distant from the radius. So that is Ix, and here is Iy, and negative, positive. Let me change the symbols here. Iyz and Iyz minus plus and Iy. Okay. So here we are given the Iyz is positive. So that means for the z point, that let me write here. For the z point on the Mohr circle, that has a coordinate, and that is given by we have 2 points. Wait a minute. I think I confuse the sign. Let me change it. Okay. So we have two components. We have 2 points on the Morse circle, and this one is given by IY and IYZ. So for this case, this one IY, we have given the number basically that is equal to I, and IY is 1.894, and then IYZ is positive 0.8. So this one times 10 to the 6 and millimeter to the 4th power. So Y should be somewhere here. And this is the center. And we make this the diameter, this is the Z. Okay? So we have from this one, then the principal directions or the orientation of the principal axis basically is corresponding to these 2 values. So here is the I maximum, and this one is for the I minimum. So we can find out the orientation is this. We simply rotate the 2 points, for example, clockwise, and making to here. So that means Z will move to this point, Y will move to that point. So that means here we rotating this angle, we can calculate this one is, let me call this is 2 theta m. So to theta m, we can utilize this triangle. For example, this is 90 degrees. So utilize this triangle. So that triangle would be something like this one. So this is 2 theta m we're looking for. And this is R, and this one is IYZ. So that is 0.8. Okay. And this one, basically the distance is the center minus the coordinate of Z. The center minus the coordinate of Z. And so that one, this one should be equal to 1.25 minus the coordinate of Z and 0.614. Okay. So that one, how much? 25.64 times 10 to the 6 millimeter to the 4th power. Okay, so here I just kind of drop off this kind of unit here. So from here you can see basically the 2 theta m will be equal to arctangent. Arctangent 0.64 and then this 0.8. So therefore we can calculate theta m will be equal to about 25.6 degrees. And this one we're rotating is clockwise. So therefore we can label our the principal axis. The principal axis is in the way, let me drag that figure down a little bit more. So this is Y, this is Z. And principal axis is in the way we rotate YZ into clockwise orientation by about 26 degrees. So we rotate YZ in the same clockwise by 25.6 degrees. So that, let me draw that one here. Okay. And this angle is 25.6 degrees. So under this situation, it's basically Z rotate to here, and let me label this as the U axis, and let me label this as the V axis. Basically, U is the transformed axis from Z. And Z, you can see on the Morse circle, the Z corresponding to is I minimum. So that means the I respect to the U axis, that should be corresponding to the I minimum. Right? And I minimum is point two. Allow me to change the symbol one more time, because this is consistent with the lecture notes which I posted onto the Blackboard. So hopefully it won't confuse you. Sorry about that one, okay? So there's a V. So that is 0.2295 times 10 to the 6 millimeter force. And IU, the moment of inertia respect to the U axis, and you can see the Y representing is the original Y axis and moving to here. So that means this is corresponding to I maximum. And this one is 2.2785. Okay. And here for your exercise, and again, your learning is this. Once you have built up the Moore circle, and for your learning is you have to know how to correctly identify which axis about that axis, what is the moment of inertia, and that is a part you have to pick it out. Because you have to translate the result from the Moore circle to there. Okay, so that is the one here. So once we have done this one, then we can proceed. And basically, U and V axis representing is the plane of the symmetry. If we extend it, that's the plane of the symmetry. So we will be able to apply the original, again, the